So this question says, sketch the graph of y equals negative 3x cubed plus 24, showing all intercepts and commenting on any transformations that have occurred to the graph y equals x cubed. So, like always, the things that we need to find are the y-intercept, the x-intercept, and the point of inflection. So let's go through and do that. We'll find the y first, and to do that we make x equal to 0. Alright, so we'll write out the equation. Y is equal to negative 3x cubed plus 24. Make x equal to 0, so we're going to go y is equal to negative 3, 0 cubed plus 24. 0 cubed is 0 times negative 3 is 0, so you're going to get y is equal to 0 plus 24, which of course leaves us with 24, so y is equal to 24. That will give us the coordinate 0, 24, because our x is 0 and our y is 24. Let's go through now and find our x-intercepts. Now to find our x-ints, we need to make y equal to 0. So let's go through and do that now. We're going to go y is equal to negative 3x cubed plus 24. And we go y is equal to 0, so we get 0 is equal to negative 3x cubed plus 24. The first thing to do now is to subtract 24 off both sides because we've only got one type of x, so we're doing inverse operations. So minusing 24, so you go negative 24 is equal to negative 3x cubed. Divide both sides by negative 3 now. Will get us 8 is equal to x cubed. And therefore, when we cube root each side now, so we go cube root of 8 and cube root of x cubed, we're going to get 2 is equal to x. Therefore, the coordinate of this point is at 2, 0, because our x coordinate was 2 and our y coordinate was 0 that we subbed in before. The last bit that we need to find now is our point of inflection. So our point of inflection will be at our BC value, so at BC. Now our B value, well, we don't actually have anything in brackets, so our B value is equal to 0, and our C value is equal to 24. So therefore the point of inflection will be at the point 0, 24, which also happens to be our y-intercept. So what we're going to do now is go through and plot those points. So we go up to our y-intercept, which is at the point 0, 24, which is right here. We write 0, 24. We go over to our x-intercept at the point 2, 0, and we write 2, 0. Now what type of graph is it? Well, we have a look at our A value, which happens to be negative 3, as you can see at the front here. So because it's a negative A value, what we're going to do is get a graph that comes down with a point of inflection and then continues to go down. So then what we're going to do is we're going to sketch a graph that comes down, goes through the point of inflection, and then comes down like so. Remember to draw arrows at each end, and then what you need to do is go through and label the graph. So we've got y is equal to negative 3x cubed plus 24. And there you go, that's how you sketch the graph of y equals negative 3x cubed plus 24. What we now need to do is go through and comment on any transformations that have occurred. So the negative 3, the A value, means that we have a dilation by a factor of 3 from the x-axis. The fact that our A value is negative means that it has been reflected in the x-axis, and the fact that we have a C value of 24 means that it has been translated 24 units up. And that there is how you sketch the graph of y equals negative 3x cubed plus 24, commenting on any transformations that have occurred.
Well now that's all well and good, so we've had a look at how to sketch the graph of cubic functions in some of their more basic forms. Let's now have a look at how to sketch the graph of cubic functions in their power function form when we've changed the values of a, b and c. So let's check that out.
Alright, so as you can see, this question says sketch the graph of y equals 2 bracket x plus 1 cubed plus 2, showing all intercepts and commenting on any transformations that have occurred to the graph y equals x cubed. Now there's a few things that we need to find in order to be able to do this. The first one is the y-intercept by making x equal to 0. The next thing is we find our x-intercept by making y equal to 0. And then we also need to find our point of inflection, which is our b and c values. So let's start off first of all by finding the y-intercept. Now we're going to write out the equation first. So we've got y is equal to 2 bracket x plus 1 cubed plus 2, and to find the y-intercept we're going to make x equal to 0, so y-int x is equal to 0, and we'll substitute that in now. So we've got y is equal to 2 bracket, and instead of writing x I write 0 in brackets because I'm substituting in, plus 1 cubed plus 2. Now what I've got to do is go through and simplify. So I've got y is equal to 2 bracket 0 plus 1 is 1 cubed plus 2. Therefore y is equal to 2 times 1 cubed. Well, it's just going to be 2 times 1 plus 2. Therefore y is equal to 2 times 1 is 2 plus 2 is 4. And my y-intercept will be at the coordinates 0, 4. Finding my x-intercepts now. So for x-ints, I'll make y equal to 0. So let's go through and do that. I've got my equation of the line, which is y is equal to 2 bracket x plus 1 cubed plus 2. Make my y equal to 0 now. So I've got 0 is equal to 2 bracket x plus 1 cubed plus 2. Now what I need to do is look at how many types of x I've got. Well, I've only got the one here, that is this x here. So what I need to do is go through and use inverse operations using BODMAS in order to be able to do this. So in order to do that, I subtract 2 from both sides. So that's going to get me, when I subtract 2 over here and here, will get me negative 2 is equal to 2 bracket x plus 1 cubed, and the plus 2 and negative 2 will cancel out. The next step to do is divide both sides by 2. So that's going to get me negative 1 is equal to x plus 1 cubed. The next step is to go through and cube root both sides. So I go cube root of negative 1 and cube root of this side here. And cube root of negative 1 is negative 1. Cube root of this side here, well, the cube root and the cube are going to cancel each other out, leaving me with x plus 1. So now what I've got to do is just subtract 1 from both sides. And that's just going to leave me with negative 2 is equal to x when the 1 and the negative 1 cancel out. So therefore the coordinates of the x-intercept is at negative 2, 0, because my x-coordinate was negative 2 and my y was 0. Now what I need to do is find the point of inflection. So the point of inflection is at the coordinates b, c. Now if I have a look at the coordinates b, c, well, my b value is actually negative 1 because it's the opposite of what you see there. So it's negative 1, and my c value is 2, so it's 2. So the point of inflection is at negative 1, 2. Now what we're going to do is just go through and plot these points. That is the 0, 4, the negative 2, 0, and the negative 1, 2. So let's go through and do that now, shall we? So we've got 0, 4, we come over here to the graph and we go 0, 4, so 0 along the x-axis, 4 along the y-axis, and I put a dot and I write 0, 4. The next one here is the x-intercept, so at negative 2, 0, so I go across the negative 2, 0 on the x-axis, do a dot and I write the coordinates negative 2, 0. Then the next one is a point of inflection at negative 1, 2, so I go across the negative 1, which is here, and I go up to 2, which is 1, 2 right here, and I write the coordinates negative 1, 2. Now what I need to do is consider, is the graph going up or down? Well, as you can see here, the dots really actually highlight what's going on, but let's have a look at our equation once more. Now to know if the graph's going up or down, what we need to do is look at our a value. Is our a value positive or negative? Well, it's positive, therefore the graph is going to be going up like this. So what we need to do is just draw a graph that goes through those three dots going up like this. So we go up here, make sure it flattens out at the point of inflection, and then comes up like so. And we draw arrows at the end. Then what we also need to do is write out the equation of the line. So you got y is equal to 2 bracket x plus 1 cubed plus 2. And the last thing that the question says is comment on any transformations that have occurred to the graph y equals x cubed. That's where we need to look at our a, our b and our c values and comment on what's actually happened. So if we have a look at our a values first, we can see that our a value is positive 2. Now because our a value is positive 2, there has been a dilation by a factor of 2 from the x-axis. If it was negative, then there'd also be a reflection, but it's not, so it's just the dilation factor. Now we have a look at our b value, and our b value is positive 1, so therefore it's been translated 1 unit to the left. because it's positive 1, it's been moved 1 unit to the left, as you can see by the graph over here. And our C value has been translated 2 units up. So, translated 2 units up. And that there is how you sketch the graph of y equals 2 bracket x plus 1 cubed plus 2 and comment on any transformations. That is, there's been a dilation by a factor of 2 from the x-axis, it's been translated 1 unit to the left and translated 2 units up. Highlighting that now, you've got 1 unit to the left because this here is negative 1, and 2 units up, so it's 1 unit to the left and 2 units up. Alright, so it's now time to press pause and attempt the following question, that is, sketch the graph of y equals negative 1/2 x minus 4 cubed plus 4, showing all intercepts and commenting on any transformations that have occurred to the graph y equals x cubed. Now remember, when you're done, to press play so you can check your answers out against mine. Alright, so welcome back. Now the very first thing I've done is gone through and looked for my y-intercept. Now in order to do that, I'll make my x equal to 0. So I've written out my equation here, and I've made x equal to 0 down in the next line. So you get y is equal to negative 1/2 bracket 0 minus 4 cubed plus 4. Now what we need to do is go through and simplify. So you get 0 minus 4 is negative 4, and then you've got negative 4 cubed is negative 64. So you end up getting negative 1/2 times negative 64 plus 4. Now negative 1/2 times negative 64 is positive 32, and when we add 4 we get 36. Now this gives us the coordinate. When x was equal to 0, we had a y coordinate of 36. Now we look for our x-intercept, so to do that we make y equal to 0, that is up here. So once again, to find our x-intercepts, we make y equal to 0. We've got y is equal to negative 1/2 x minus 4 cubed plus 4. Now make y equal to 0, so instead of writing y I write 0, and that gets us 0 is equal to negative 1/2 x minus 4 cubed plus 4. Now what we need to do is go through and solve for x. Now I need to look to see if I need to factorize or to solve by using inverse operations. Well, how many different types of x have I got? Well, it's just the one. So therefore I use inverse operations. So I go through and I subtract 4 from both sides. Subtract 4 gets us negative 4 is equal to negative 1/2 x minus 4 cubed, and we've got the positive 4 and negative 4, they cancel out, so that's all it is. Then what we need to do is go through and multiply everything by negative 2 in order to get rid of the negative 1/2. So negative 4 times negative 2 is positive 8, negative 1/2 times negative 2 cancels it out, leaving us with x minus 4 cubed. In order to get rid of the cube now, what we need to do is cube root everything, so you go cube root of 8 and cube root of x minus 4 cubed. Cube root of 8 is 2, and the cube root and the cube cancel each other out, leaving us with 2 is equal to x minus 4. Now what we need to do is go through and add 4 to both sides, so you go plus 4, 2 plus 4 is 6, and x minus 4 plus 4, well, the 4's will cancel out, so you get x is equal to 6. Therefore the coordinate of this point is, well, x is equal to 6, and our y was equal to 0, so we get 6, 0. Going through now and finding our point of inflection, we've got that at the point BC. Now our B was equal to 4, because if you have a look up at the equation up here, it's the opposite of negative 4, so B is equal to 4, and our C is equal to 4, which you can see here. So the point of inflection is at the point 4, 4. Now what we're going to go through and do is plot each one of these points. So the y-intercept first of all at 0, 36, so it's 30, 32, 34, 36. Then what we do is plot it at the point 6, 0, so we've got 6, 0 here, and at the point 4, 4, so you got 4, 2, 4 here, and what we're going to do is label each one of these points, so 0, 36, 4, 4, and 6, 0. Now what we need to do is just go through and join the dots, but in order to be able to do that, what we need to do is just look at our A value quickly. So let's come up to the top part here, where we've got our A value is equal to negative 1/2. Now because it's a negative, we know that our graph is going to be going down like so. So therefore what we're going to do is make sure that we've got a gradient of 0 at 4, 4, and we have a graph that comes down here, goes through the 4.44 with a flat gradient, and then comes down like so. Make sure you draw arrows on each end, and then what you're going to do is write the equation of the line. So you go y is equal to negative 1/2 x minus 4 cubed plus 4. The last part of the question says state any transformations that have occurred to the graph y equals x cubed. Well, from our a value, we know that it's been dilated by a factor of 1/2 from the x-axis. Remember, we only talk about the positive value of the dilation factor, but then the negative value out the front of the 1/2 means that it's been reflected in the x-axis. In terms of translations, well, it's been translated 4 units to the right because of our b value being -4, and it's been translated 4 units up because our c value is +4. And there you go, that's how you sketch the graph of y equals -1/2 x minus 4 cubed plus 4.